Hey guys, welcome back. Today we're talking about what a system is. Yes, we're going to learn what it means to be a system. Our learning target is going to be to solve a system of two equations in two variables. I'm going to actually highlight that. That's basically what a system is. It is a set of equations, so multiple y equals mx plus b's, or they could also be in other forms, but you're going to see two equations. Our success criteria for this is going to first be I can describe what it means to be a solution to a system of equations. We're going to talk about what that really means in context, a solution. I can explain what a solution of a system means given a real world context. So we're going to focus on what it means. Okay, and remember, when I say context, that means in the real life situation. So let's take a look at the key idea. So the main idea, the key concept of this lesson is basically to understand what a system is, and we should be able to construct a system out of a context. So a system of linear equations is two or more linear equations. So really what I'm looking for you guys to be able to construct are two lines of math that have equal signs in them. If they don't have an equal sign, it's not an equation. So, and they have to have the same variables. So if you feel there's more than two things changing, then it's most likely not going to be solvable. So let's take a look at this situation. I actually wrote the situation two times, only I highlighted the two different sentences that we're going to translate into a mathematical sentence. So I have one pencil and one marker cost $1.50. So I showed that in a visual. So I have a pencil plus a marker is equal to $1.50. Let's represent pencil with P. Whoop, that's a little bit too big. Scale that down a little bit. Okay, so let's represent pencil with P and marker with M. That equals 150. So I just created an equation in two variables. So now I have to create a second equation because there are two variables. The amount of equations should match the amount of different variables. So that's where this second sentence comes in. Two pencils and one marker cost $2. So as you can see, I got you a picture of two pencils plus a marker equaling $2. So let's call that two pencils, 2p, plus one marker, M, is equal to $2. And now we've actually constructed a system. The ultimate question does say, what are the cost of one pencil and the cost of one marker? We will be learning how to solve this type of system algebraically eventually, but for now, we're just going to construct them and be able to graph them. In fact, most times that you see a system, you'll see the equations stacked on top of each other. So I'm just going to write that over here. I'm going to write the first equation, P plus M is equal to $1.50, and 2P plus M is equal to $2. And some math textbooks will also put a bracket next to them, just like that, so that you can tell that those two equations go together. So we are eventually going to learn how to solve a system like this. In fact, some of you may even be thinking, Miss S, this is a pretty easy problem to solve. If you think about it, the only difference between $1.50 and $2 is that 50 cents. And the only difference between the two equations is that this has two pencils, whereas this only has one pencil. So some of you may have already been able to logic your way into knowing that the pencil costs 50 cents, or $0.5. Okay, and that means the marker, since the pencil is worth 50 cents, the marker must be worth $1. Okay, now the systems are not going to be that easily logicked through all the time. So we need to have some methods in order to solve these systems. The second idea here behind a system is the solution to that system, and it's incredibly important, and I want you guys to highlight this. It is incredibly important that we understand that a solution to a system is an ordered pair. Okay, ordered pair, that means it's going to be a point. Okay, I'm going to write that. It's going to be a point or a coordinate. you're going to need to figure out what x and what y are, and I do want the solution to be written in the way of a point. I don't want to see just x equals y equals. I want to see you put it in the form of a coordinate pair as your answer. So let's take a look. This is the same situation with the pencil and the marker. It says the solution of the system is 0.51, as we kind of logicked our way through a moment ago. The values for the variables p and m that make both the equations true. So if we were to verify this, it has to be true in both of the equations. So let's substitute 0.5 in for x and 1 for y in both equations. Sorry, not x and y, my apologies, p and m. So this was p and this was m. So I'm going to plug into this equation 0.5 instead of p plus 1 instead of m. Does that equal 1.5? So if this is true, if this line of math is true, then it is a solution, which I know that 0.5 plus 1 is 1.5. So since 1.5 is equal to 1.5, so far so good. But don't think it's a solution just yet. We need to make sure that the point also fits in the second equation. If it doesn't fit in both, it is not a solution. So let's check. 2 times p, which was 0.5, plus the marker m, which was 1, is equal to 2. Well, 2 times 0.5 is 1. So I have 1 plus 1. Does that equal 2? Yes, it certainly does. So this is, in fact, the solution to the system. And that's what we're going to have to do. Every time we find a point that we think is the solution to the system, we should be verifying it to make sure. So the last piece of this key idea is that the solution to a system of linear equations is the point of intersection. I'm going to highlight that again because that is one of the most important things we need to remember. The point of intersection on the graph. So wherever the two lines intersect, that's the solution. So that's why we were verifying that this point, that why it's in an ordered pair, because it is the point where the two lines, when we graph them, meet. So if you take a look at the situation here, they've graphed the two equations that we came up with. The 1 pencil plus 1 marker equaling $1.50, that's the line in blue. The 2 pencils plus a marker equaling $2, that's the line in red. And then the point where they intersect, okay, at 0.51, sorry about that, right here, 0.51, that's going to be your solution. And you can tell, if we were to zoom in here, okay, it looks like on the x-axis they're counting by 2s. Okay, so this would, or this, counting by 1s, excuse me, 1, 2, 3, and then there's 4. So you can tell if I were to line up where this point is, that looks to be about 0.5. And then if I were to look at where the y value is, that looks to be 1. So it matches up with that coordinate, and that's where the two lines intersect. So we're going to practice not only figuring out where two lines meet, but we're going to practice graphing as well. So let's take a look at the first example. It says, determine whether each of the following represents a system of linear equations. So right now, we're just going to identify which ones are actually systems. Remember, it has to have two equations with the same variables, 2 or more. So I can already tell that this, and this one, since there's only one line of math written, they could not possibly be a system. This one is definitely an equation, so it had more potential to be a system because of that equal sign. Okay, but there needs to be 2 of them, so it is not a system. I'm going to put that in the category of not a system. So we had 2x plus 3y equals 6 is not a system. This one here, or both of these guys, are called expressions. Okay, that's why sometimes on your worksheets, it'll say simplify the expression instead of solve the equation. An equation is something where you can figure out the variables. An expression, since they're not equal to anything, you're not going to be able to figure out what their solutions are. So I'm going to put those in the not a system category as well. 14x minus 24y. And lastly, 5x minus 7y. Those are not systems. The others, I'm going to check out because I do see 2 lines of math on all of them. In fact, I see an equal sign and an equal sign, equal sign and an equal sign, equal sign and an equal sign. So far, I'm seeing that all of them have at least 2 equations. I'm also seeing that, let's just take a look at this first one here. There are only 2 variables. So we have x and we have y. So this one is a system. And I'm actually going to put brackets around them just so that I can separate the different systems in this category. So I'm going to put a bracket, y equals x and y equals x plus 5 is definitely a system. The second one here is also a system. So because I'm seeing 2 different variables and 2 equations, x equals, x equals 2 and y equals negative 3. And then we have one more system here, y equals 1.5x and y equals 2x minus 1. And that is definitely also a system because, again, I only see 2 variables in 2 equations. Let's see how you do on your U-Try. All you're doing is identifying which are system of linear equations. Alright, so I have one last example for you guys, and it's a real-life situation, and we're actually going to construct the system for it. We're not going to solve the system, I just want to practice creating them. It says, wildlife biologists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown in the table. Write a system of equations the biologist could use to compare the weights of the alligators. So what I want you guys to notice here in this situation is I'm seeing initial value and a rate of change. They even say this in the actual tables themselves, so I'm going to highlight that because that should be reminding you of y equals mx plus b. Remember, the initial value is going to be your b, and your rate of change is going to be your m. I'm going to label that in the table. So this is the y-intercept, and this is the slope. So we're going to be constructing 2 equations in the form of y equals mx plus b. We're going to be constructing equations in other forms as well, other than y equals mx plus b, but if you recognize the titles indicating a y-intercept or a slope, that's what should be coming into your mind. So the first equation we'll say is for the first alligator. I'm going to call that A1. So again, I'm going to write it in the form y equals mx plus b. So y equals, I'm going to fill in the spot for m, and I'm going to fill in the spot for b. Okay, the m for alligator 1 is 1.5. So I'm going to fill that in, 1.5 for m, and then the b is 4. So there's my first equation. Now the second equation is going to represent the second alligator. So A2, their equation is going to be a slope of 1. So y equals 1x plus their initial value is 6. So my system, if I were to write it stacked on top of each other, would be y equals 1.5x plus 4 and y equals x plus 6. I didn't write the 1 just because usually you don't have to write the 1. Remember, it can be invisible. And I put my little bracket next to them showing that they are together as 1. So why don't you guys give this a try in your U-Try? All right, so that pretty much wraps up our first lesson on systems. Remember, today we didn't quite solve them ourselves, but we did verify certain solutions, and we did describe what it means to be a solution to a system, as well as explain what a solution of a system means given a real world context. So if you have any questions, please let me know. You may now go ahead and get your start on your practice.